Good morning, everyone. This is Mrs. Elisa D. Edgar, and this is your General Mathematics class. For this quarter 1, week 1, we have functions. Our learning competency or competencies for this lesson is that the learner will be able to represent real-life situations using functions, including piecewise function. Definition. Relation is a rule that relates values from a set of values, called the domain, to a second set of values, called the range. It is a set of ordered pairs x and y. For the function, it is a special type of relation where each element in the domain is related to only one value in the range by some rule. It is also a set of ordered pairs x and y, such that no two ordered pairs have the same first element, which is the x. Every value of x corresponds to a unique value of y. Examples. Which of the following relations are functions? We have the relation f, g, and h. The relations f and h are functions because no two ordered pairs have the same x value but different y values. Meanwhile, g is not a function because element 1, 3, and 1, 4 are ordered pairs with the same x value but different y values. Another representation of function is using mapping diagram. Which of the following mapping diagrams represents function? We have f, g, and h. The relations f and g are functions because each x is an element of the domain corresponds to a unique y, which is the element of the range. The relation h is not a function because there is at least one element in x for which there is more than one corresponding y value. For example, x equals 7 corresponds to y equals 11 or 13. Similarly, x equals 2 corresponds to both y equals 17 or 19. Vertical line test. This is a graph represents a function if and only if each vertical line intersects the graph at most once. Another way of representing function is by graph. Which of the following graph can be a graph of functions? We have A, B, C, D, and E. Graph A, B, C are graph of functions while D and E are not because they do not pass the vertical line test. Important reminders or important concepts about relations and functions. Relations are rules that relates two values, one from a set of inputs and the second from the set of outputs. Functions are rules that relate only on value from the set of outputs to a value from the set of inputs. Another example of representation of a function is by equation. So which of the following represents a function? For A, we have the equation y, which is equal to 2x plus 1. B, which is y equals x squared minus 2x plus 2. C, which is x squared plus y squared equals 1. D, which is y equals square root of x plus 1. And E, which is y equals 2x plus 1 over x minus 1. All are relations. All are function except C. Equation C is not a function because we can find an x value that corresponds to more than one value of y. For example, if x is equals to 0, then y can be positive 1 or negative 1. Functions as representation of real-life situations. Functions can often be used to model real-life situations. Identifying an appropriate functional model will lead to a better understanding of various phenomena. Example: give a function c that can represent the cost of buying X meals if one meal costs 40 pesos. Since each meal costs 40 pesos, then the cost function is c of x equals 40x. Some situations can only be described by more than one formula, depending on the value of the independent variable. Therefore, we can have this piecewise function. Piecewise function is a function defined by multiple subfunctions where each subfunction applies to a certain interval of the main function's domain. Example: a user is charged 300 pesos for a particular mobile plan, which include 100 free text messages. Messages in excess of 100 are charged 1 peso each. For A, how much will a consumer pay if he had 85 text messages? What about 150 messages? B, represent the amount a consumer pays each month as a function of the number of messages M sent in a month. For A, for consumer who will have 85 text messages will pay 300 pesos. For 150 text messages, a consumer will pay 350 pesos. The cost of text messaging can be expressed by the piecewise function, wherein T of M equals 300 pesos or 300 if the number of messages is between 0 and 100. Another subparts of the equation or the formula is we have 300 plus M if M is greater than 100. Another example is when we ride jeepney. A jeepney ride costs 8 pesos for the first 4 kilometers, and each additional integer kilometers adds 1.50 pesos to the fare. Use the piecewise function to represent the jeepney fare in terms of the distance d in kilometers. The input value is distance and the output is the cost of the jeepney fare. If f of d represents the fare as a function of distance, the function can be represented as follows. F of d equals 8 pesos if the distance is between 0 and 4, and 8 plus 1.50 of d if the distance is greater than 4. The symbol d denotes the greatest integer of floor function applied to d. The floor function gives the largest integer less than or equal to d. Example, 4.1 or 4.9 is still equal to 4. And that's all for today's lesson. Thank you for listening. Handang isip, handang bukas. Tara, ML na tayo.
Hello students, I am Marvici Flores, your teacher in General Mathematics. Our lesson 2 for week 1 is all about evaluating functions. For our objective, at the end of the lesson, you are able to evaluate functions. Let us define first the procedure in evaluating functions. Okay, in evaluating functions, replacing the variable in the functions, and in this case, x with a value from the function's domain and computing for the results. So, let's have our example in example number 1. Evaluate the following function at x is equal to 3. So, for letter A, f of x is equal to 2x plus 1, where x is equal to 3, we're going to substitute it. So f of 3 is equal to 2 times 3 plus 1. And 2 times 3 is equal to 6 plus 1, where 6 plus 1 is equal to 7. 7 is the value of the given function. Next example, g of x is equal to x squared minus 3x plus 5. Okay, again, substitute the value of x, that is 3. So g of 3 is equal to 3 squared minus 3 times 3 plus 5. Simplify it further. 3 squared is equal to 9, while negative 3 times 3, that is negative 9 plus 5. Then, okay, copy 9, and because negative 9 plus 5, okay, they're unlike sign. Okay, so just subtract. So 9 minus 5, that is 4. And then get the sign of the highest number, so negative 4. Then 9 minus 4, that is equal to 5. So it means the given function is equal to 5. Next example. What about h of x is equal to square root of x plus 1? And again, x is equal to 3. So, h of 3 is equal to square root of 3 plus 1. And that is equal to square root of 4. And while square root of 4 is equal to 2. Okay. Another example. What about p of x is equal to x squared plus 1 all over x minus 1, where x is equal to 3. So, we're going to substitute. Okay, p of 3 is equal to 3 squared plus 1 all over 3 minus 1, where 3 squared is equal to 9 plus 1 all over 2. Why 2? Okay, from our denominator, 3 minus 1, that is 2. Okay, again. Okay, 9 plus 1, that is 10. Then divided by 2. And 10 divided by 2, that is 5. Okay, last example for this part. F of x is equal to the absolute value of x minus 5. Substitute the value of x again, that is 3. So we have f of 3 is equal to the absolute value of 3 minus 5 is equal to the absolute value of 2, and the absolute value of 2 is and the absolute value of negative 2 is 2. Okay, so next for additional examples. Okay, example number 2. Evaluate the following functions where f and q are as defined in example number 1. Okay, we're going to use this f of 3x minus 1 as value of x, 3x minus 1. Okay, then use this function. F of x is equal to 2x plus 1. We're going to substitute this 3x minus 1 as the value of x. So, f of 3x minus 1 is equal to 2 times 3x minus 1 plus 1. So, use distributive property of multiplication to simplify it further. So, 2 times 3x, that is 6x. Then, 2 times negative 1, that is negative 2. Then, plus 1. Okay, combine like terms. Copy 6x, while negative 2 plus 1, they are unlike signs, so subtract. So, 2 minus 1 is equal to 1. Then, get the sign of the highest number, that is negative, so negative 1. So, the final answer is 6x minus 1. Okay, next example. Okay, we're going to use this 2x plus 3 as the value of x. Okay, we're going to use this function. Q of x is equal to x squared minus 2x plus 2. And as value of x again, 2x plus 3. So, substitute it. Okay, so this is 2x plus 3 squared minus 2 times 2x plus 3 plus 2. In order to simplify it further, we're going to use, or we're going to expand. Okay, okay, yes, okay. We expand 2x plus 3 squared, so 2x plus 3 times 2x plus 3. Well, in this part, we're going to use distributive property of multiplication. So, negative 2 times 2x, that is negative 4x, and negative 2 times 3, that is negative 6, then plus 2. Okay, useful method. Okay, and simplifying this part. So 2 times 2x, that is 4x squared. While for this middle term, okay, we have 2x times 3, that is 6x, plus 3 times 2x, another 6x. So 6x plus 6x, that is 12x. Then for the last term, we have 3 times 3, that is 9. Okay, so again, 4x squared plus 12x plus 9, okay, in performing full method. While this one, we need to combine like terms only, okay. Negative 4, you just copy negative 4x, okay, while negative 6 plus 2, we're going to combine. Why? Because they are like terms and they are unlike signs. So we're going to subtract, okay. 6 minus 2, that is 4. Why negative? Because the sign of the highest number is negative. So again, combine like terms for the final process. Okay, copy 4x squared. Okay, then 12x minus 4x. They are unlike signs, so we're going to subtract. 12x minus 4x, that is 8x. Why positive? Get the sign of the highest number. Then, for the last part, okay, the last term, okay, positive 9, negative 4, they're also unlike signs. So we're going to subtract again. Okay, 9 minus 4, that is 5. Why positive? Okay, the sign of the highest number. So it means, okay, the value of the given function is 4x squared plus 8x plus 5. Okay, to sum up our discussion, this is our generalization. To evaluate a function, substitute the value in the given function with the given value from the function's domain and then simplify it for the result. Okay, so remember this. Handang isip, handang bukas. Tara na, ML na tayo. This ends our lesson. Hoping you have learned something. See you again for the next lesson. Bye, class.
Hello, everybody. Good day to all of you. Today, we will have another topic, and this is already our lesson 3. This is all about operations on functions. Operations and functions, we have to know first what are the objectives. So we only have 2. Perform addition, subtraction, multiplication, and division. The second is solve problems involving functions. And of course, I am expecting that all of you will be able to perform addition, subtraction, multiplication, and division of functions. Okay, to start with, let's have a short review. This is all about algebraic expressions. So if you're familiar with those things, let's start with addition and subtraction. You have to find first the LCD, or the least common denominator of both fractions. Second, rewrite the fractions as equivalent fractions with the same LCD. Third, the LCD is the denominator of the resulting fractions. Fourth, the sum or difference of the numerators is the numerator of the resulting fraction. So let's have example 1. Find the sum of 1/3 and 2/5. The LCD of the two fractions is 15. So you have 1/3 plus 2/5 is equal to the new LCD, which is 15 to be used, and you will have the resulting fractions 5/15 plus 6/15. You add the numerators together and copy the same denominator, and you will have the result, or the answer, which is 11 over 15. Our second example, you have to find the sum of 1 over x minus 3 and 2 over x minus 5. So the LCD of the two rational expressions is x minus 3 and x minus 5, or x minus 3 times x minus 5. And this can also be written as x squared minus 8x plus 15. Either of the two can be used as your least common denominator. So writing the given 1 over x minus 3 plus 2 over x minus 5, you will have the denominators x minus 3 times x minus 5, and the resulting fraction of the first given is x minus 5 over x minus 3 times x minus 5. The second one is the resulting fraction is 2 times x minus 3 over x minus 3 times x minus 5. So you will just simply combine together the x minus 5 and 2 times x minus 3, and the result is 2x minus 6. That is already the simplified form of 2 times x minus 3. So we have x minus 5 plus 2x minus 6 over the denominator x squared minus 8x plus 15. Now, how did it happen? I've shown you a while ago that either of the two fractions, or the denominator x minus 3 times x minus 5, can also be written as x squared minus 8x plus 15. And the final answer will be 3x minus 11 over x squared minus 8x plus 15. I hope you guys can follow. Second is multiplication. So how do you do the multiplication? First step, rewrite the numerator and denominator in terms of its prime factors. Second, common factors in the numerator and denominator can be simplified as 1. This is what we call the cancellation method. Third, multiply the numerators together to get the new numerator. And the last one, multiply the denominators together to get the new denominator. Let's have the next example. How do you find the product of 10 over 21 and 15 over 8? Take note, you can use cancellation of factors when convenient or if necessary. So express the numerators and denominators of the two fractions into their prime factors. After that, you have to multiply and cancel out common factors in the numerator and the denominator to reduce the final answer to lowest term. Answer should always be expressed in lowest term. So we have 10 over 21 times 15 over 8. Factor out all the given numbers. For 10, we have 2 times 5. For 21, we have 3 times 7. For 15, 3 times 5 are the prime factors, while 8 has 2 times 2 times 2 as its prime factors. So, canceling out numerators and denominators together, 2 and 2, 3 and 3. So, what is left? We have 5 times 5, which is 25. And we have 7 times 2 times 2, which is equal to 28. Final answer, 25 over 28. The fourth example is for you to find the product of. We have the two fractions here. X squared minus 4x minus 5 over x squared minus 3x plus 2. And x squared minus 5x plus 6 over x squared minus 3x minus 10. So how do you do this? First, you have to express the numerators and denominators of the two rational expressions into their prime factors. Multiply and cancel out common factors in the numerator and the denominator to reduce the final answer to lowest term. And the last is to have to take note of the similarity in the process between this example and the previous one on the fractions. So we have, these are the given rational expressions, and this will be equivalent to this x plus 1 times x minus 5. It's being factored out over x minus 2 times x minus 1. And the second rational expression is x minus 2 times x minus 3 over x minus 5 times x plus 2. What's next here? Okay, we have to cancel out possible numbers in the numerator and the denominator. So we have x minus 5 together and x minus 2 together. One from the numerator and one from the denominator. So the next step is for us to obtain the final answer. What is left? We have x plus 1 times x minus 3 in the numerator, and our denominator is x minus 1 times x plus 2. So we have the final answer, x squared minus 2x minus 3 over x squared plus x minus 2. I hope you got this, guys. What's next is division. To divide two fractions or rational expressions, multiply the dividend with the reciprocal of the divisor. When we talk about reciprocal, it is the multiplicative inverse of the given number or expressions. Example, you have to divide 2x squared plus x minus 6 over 2x squared plus 7x plus 5 by x squared minus 2x minus 8 over 2x squared minus 3x minus 20. It's quite long, guys, but I think it's just easy for us as long as we know the principle behind division of algebraic expressions. So for us to solve it, of course, when we say division, get the reciprocal of the divisor. When we say divisor, the second expression is the divisor. 2x squared plus x minus 6 over 2x squared plus 7x plus 5 times the reciprocal of the given divisor, 2x squared minus 3x minus 20 divided by x squared minus 2x minus 8. So what will we get here? So we have 2x squared plus x minus 3 times 2. Why do we have 3 times 2 here? I was able to factor out the number 6. Same through with the denominator. I just want you to show how do I factor it so that you can easily cancel out some of the given numbers. So it's the same through with the divisor. 3 times x being factored out, 4 times 5 for 20, 2 times x, and 4 times 2 for the number 8. Let's proceed to the next one. Okay. 2x squared together, cancel out. X and x, 2 and 2. 2, another 2, and then here. And then the 5, and then the 4, the x, and the x squared over x squared. Now, what is left from these expressions? Okay, we have 3 times 3 in the numerator and just simply 7 in the denominator. So, final answer is 9 over 7. Okay, so let's go now with our main lesson. We have the operations on functions. It says here, functions with overlapping domains can be added, subtracted, multiplied, and divided. If f of x and g of x are two functions, then for all x in the domain of both functions, the sum, difference, product, and quotient are defined as follows. The first, their sum, denoted by f plus g, is the function denoted by f plus g of x equals f of x plus g of x. Second, their difference, denoted by f minus g, is the function denoted by f minus g of x equals f of x minus g of x. Third, the product denoted by f times g is the function denoted by f times g of x equals f of x times g of x. The fourth is the quotient denoted by f over g is the function denoted by f over g of x equals f of x over g of x. So these are the four important principles you have to remember in the operations on functions. Okay, let's proceed. We have to use the following functions for us to solve example number 5. Okay, so for the given functions, we have f of x, p of x, v of x, g of x, h of x, and t of x. And for the example, we have to solve the following functions. V plus g of x. Second, f times p of x. Third, f plus h of x. Fourth, p minus f of x. And fifth, v over g of x. Excuse me. So this is clear. You have to write down first, or we have to determine the given functions. Okay, it's on the left side. These are the given, and solve the 5 examples. So let's start with the first one. The first one says the v plus g of x, it will be v of x plus g of x. Substitute the v of x, same through with the g of x. So we have x squared plus 5x plus 4 plus the g of x, which is x squared plus 2x minus 8. What do we get from here? Combine similar terms, just like solving algebraic expressions. X squared together, 5x plus 2x together, and 4 and 8. So we have, final answer is 2x squared plus 7x minus 4. Let's go with the letter B. This involves multiplication of functions. So f of x times p of x. Substitute both with the given. We have x plus 3 times 2x minus 7. So we have to use the distributive property. X multiplied by 2 times x, or 2x, and then x multiplied by negative 7. So from these two, we will obtain x times 2x minus 7x. The second term to be distributed or multiplied is 3 multiplied by 2x, and 3 multiplied by negative 7. So we have these two here. What do we get in multiplying the following numbers? So we have x times 2x, 2x squared, 7x, negative 7x rather, plus 6x, we will have negative x. And then 3 times negative 7, we will have negative 21. And we obtain the final answer here, 2x squared minus x minus 21. The third, we have f plus h of x. This is addition of functions. Substitute the given, x plus 3 added to x plus 7 over 2 minus x. So in this case, we have to find out the LCD. Take note, this is not a fraction, the x plus 3. This is understood to have a denominator of 1. So 2 minus x will be the least common denominator of the two fractions. 2 minus x divided by 1 will be 2 minus x multiplied by x plus 3. We obtain these two expressions. The second one is 2 minus x divided by 2 minus x will just simply give you 1 multiplied by x plus 7 will give us x plus 7. So what's next? We have to simplify. So 2 minus x times x plus 3, you will get the following. 2x plus 6 minus x squared minus 3x. And of course, the second fraction here, which is x plus 7. Combine similar terms. What do we get? Negative x squared plus 13 over 2 minus x. And that is, we have to multiply negative 1 to the numerator and the denominator. Why? For us to eliminate the negative sign on the first part of the given expression. So the final answer will be x squared minus 13 over x minus 2. So let's proceed with the fourth, our second to the last example. Now we have subtraction of functions, p minus f of x. This will just simply be p of x minus f of x. Substitute the given, 2x minus 7 for the p of x minus x plus 3 for the f of x. And we will have the 2x minus 7 minus x minus 3. The final answer is x minus 10. I hope you are getting the lesson clearly, guys. So let's have the last one. Obviously, it's the division of functions. We have v over g of x. Obviously, you will get, or you will have here v of x over g of x. Substitute the two, x squared plus 5x plus 4 over x squared plus 2x minus 8. So how do we do it? This can be written also in this way, not in the fraction form, and they're just the same. So we use the division sign, and take note, the second expression is our divisor. And what is the rule if we are dividing fractions together? We get the reciprocal of the divisor. So the reciprocal of x squared plus 2x minus 8 is 1 over x squared plus 2x minus 8. Once we get the reciprocal, we have to multiply it with this first expression. So x squared plus 5x plus 4 times 1 will give you x squared plus 5x plus 4. All over x squared plus 2x minus 8. This is the final answer for v of x over g of x. So that's clear. So if you have any questions, maybe we can use the messenger, or you can send a message, or message through text, through chat. So everything will be clear for you. I'm just ready to answer also whatever questions you will come up with. Alright, let's go to the last part, which is our home enrichment. So this is just simply 10 points. You're going to solve the following functions. We have only 4. So you have to find the sum of the two functions, the quotient. Number 3 is the difference, while number 4 is for you to get the product. Okay, so we'll be meeting again the next time for our schedule, and I am expecting that everybody will get a very good score for this. So I'll see you again. Thank you, and God bless.